And they want us to find the area that is inside both of these. Yeah, so in this case, so do you see how let's go from green to red.
Oh, because that's over here.
Correct. So from green to red. And then we could go from red to, if we wanted to go from red to yellow.
Is that like supposed to be where it changes, like the one that's closest to the
Correct. And then if we wanted to go to purple. Okay, but look at this, guys. So this is the thing that, if I were to, and you know that's angled a little bit different than that, but do you see how really one of those is reflected about the red line and reflected about the green line and reflected about the purple line? So if I just had this, based on the look of these peanut looking guys, it sure seems like one of those times 4 is going to give me the total area that is inside both curves.
Can you just make that assumption?
Now, the way that the polar curves act with just sine and cosine and stuff like that, you're going to have symmetry based on one phase value. Yeah. So, what I can do is I can do my assumption, and then I could do find each of the 4 independently, add those together, and see if it's going to be the same value. Okay, so the first thing though is, let's talk about this. So let's call this theta 1 and that theta 2. How do I find those theta values? Yeah, set the r's equal to each other. So I'm going to call, this one is the blue, so I'll call that R1, and this is the red, so I'll call that R2. Right, so I'm going to set R1 equal to R2 and solve. So I'm going to get 2 plus cosine 2 theta equals 2 plus sine of 2 theta. So subtracting 2 from both sides, I get that sine of 2 theta equals cosine of 2 theta. Okay? So inside is the exact same thing. It's 2 theta. So I could, in my mind, say, I want to call alpha equal to 2 theta. So this is really sine of alpha equals cosine of alpha. Does that make sense? Because the inside is exactly the same. So what is alpha, or what is 2 theta? Such that sine of that thing is equal to cosine of that thing. Pi over 4, and also what? 5 pi over 4. So it's pi over 4 plus pi n. So I know that 2 theta is equal to pi over 4 plus pi n. So then I'm going to divide by 2 and get that theta equals pi over 8 plus pi halves n. Does that make sense? Question.
How do you know when to add pi and when to add 2 pi?
So I know that sine and cosine are equal in quadrants 1 and 4. Sorry, 1 and 3. Do you agree with that?
Mm-hmm.
So I can see that the sine and cosine values are the same at pi over 4. Not 3 pi over 4, 5 pi over 4. Not 7 pi over 4, right? So you keep going around and around, and it's those quadrants, which are 1 and 3, which are pi radian away from each other. If you're looking at like where the cosine values are equal to some, let's say, positive value, those are on the right half of it, which are quadrants 1 and 4. Or where sine is positive, those are quadrants 1 and 2, right? So it's all based on what you have. Here, I could have divided both sides by cosine of 2 theta to get that tangent of 2 theta is equal to 1. So that gives me, tangent, which tangent is positive in quadrants 1 and 3, which are pi radians apart. So it's all based on what the trig values are trig functions are that you're dealing with. Did that answer your question or no? So if this were just, where is sine of what angle is equal to 1/2? Well, in which quadrants are sine positive? 1 and 2. So 1, what do you add to 1 to get to 2? Nothing. So for 1, it's those values plus 2 pi n to get you back to quadrant 1. And for whatever that angle it is for quadrant 2, you keep adding 2 pi n to get to quadrant 2.
So then that would have 2 answers?
Correct. It'd be this plus 2 pi n or this plus 2 pi n. This one happens to be, also has 2 answers if you think about it like that, but it's pi over 4 plus 2 pi n and 5 pi over 4 plus 2 pi n. But we notice that those are only pi units apart, so you can combine them into just pi over 4 plus pi n. So this really has the 2 answers also, but it's just merged together because they happen to be pi radians apart.
You can only do it if they're pi radians.
Correct. Otherwise, everything else is plus 2 pi n. Yeah. Okay. And again, that's not a calculus thing, but that's a valid question, right? So here we have theta equals pi over 8 is what I think my theta 1 is going to be. And theta 2, what is pi over 8 plus 4 pi over 8? 5 pi over 8, which is slightly more than pi halves, which is right there, so it's a little bit more. So let's check this out. Let's plug in 2 plus cosine 2 theta into my calculator for R1. And 2 plus sine of 2 theta. Right? Isn't that what I had for my R1 and R2? Okay. And now let me go to my window and really quickly, this doesn't give me any sense, but I want to point this out for what I'm going to choose for my x and y values. I already know that my theta values are going to go from pi over 8 to 5 pi over 8. But for my x and y values, what's the greatest value that sine of anything can be? 1, right? So what's the greatest r value that I could possibly have? For r sub 1 and r sub 2, it would be 3. So I could go, so what I'm going to do is negative 3 to 3 and negative 3 to 3 for my x's and y's. Does that make sense why I'm choosing that? So now for my window, for my theta min, I'm going to say pi over 8. And my theta max, I'm going to say 5 pi over 8. Theta step, I have 0.01 to be more accurate. My theta min, I'm going to go from negative 3. Theta max is going to be 3. Y min, negative 3. Y max, 3. And so let's go ahead and graph this. Oh, I don't have them graphing simultaneously, but that's an option that you could have it do. So it goes from there, and then this is R2, goes from there. Isn't that what I wanted? Right? Going from there to there, that's exactly what I wanted there. Now really I'm looking for only the inside area, going from the pole out to that point of intersection and from the pole out to that point of intersection. But that's what I wanted. So again, under mode, right now I happen to have it under sequential instead of simultaneous. So if you wanted to see them graphed at the same theta values, you would go to simultaneous. And as a quick little note, for R2, just so I can distinguish between R1, if you go over here, obviously for the colored calculators, you're going to have a different color on the screen, which is nice. But if you just have the greenish, gray, whatever background with the black, then if you go over here and do that, then now R2 is bold. So now let's graph this, and it's going to graph them simultaneously, right? So this is for the same theta values, it's going through, and I can see that my R sub 2 is the bold one, so that's the one that's above, right? Which is what I knew. So that's just a way to verify that I accurately solved for my theta values, which are the limits of integration, which Katie said is difficult sometimes to find your limits of integration to start with, right? So now that we have those limits of integration, and we have a good understanding of what we're looking to find, which is only sweeping through, remember, because that's how we think about area now, not as moving from left to right, but sweeping through as that angle value, theta value sweeps through. So I'm going from there, only out to the blue, and I'm sweeping through. All the way until I get to that red theta value, which is 5 pi over 8. Okay? So now, just that area, and then I'll multiply by 4 later, but just that area of that region, I don't know what I just did, just the area of that region is equal to 1/2 times the integral from pi over 8 to 5 pi over 8 of something squared d theta. So what is it, which one am I going to? 2 plus cosine 2 theta or 2 plus sine 2 theta?
Cosine 2 theta.
And how did you know that it was going to be 2 plus cosine of 2 theta? Because that's the one that I'm going out to, which is the blue one, which is closest, right? So I'm going to put 2 plus cosine 2 theta in there. And now I know that in my calculator I have that stored as R sub 1. Let me just verify that that's R sub 1 before I do what I'm going to do. So it is R sub 1. So now I'm going to hit second quit. I'm going to say, so let's clear what's on there. 0.5 times math 9. Don't forget that 1/2 out in front, right? Going from pi over 8 to 5 pi over 8 of bars, y bars, polar R1 squared d theta. This gives me that value. So then I would multiply it by 4 in order to get the total area that is inside both. .480 is what I would say. So I'm going to go back to this and say total area is approximately